everyone. Now suppose the packet destination address is here 200.150.68.118.118. Now this is the destination address that is included in this incoming packet, which has come to router. Now routers will send this packet to any one of these links, either interface 1, 2 or 3 or 4 or 0, whatever it may be. So for that, what it does actually is from this destination IP address, it will extract the IP prefix, and if this IP prefix matches with any of this IP prefix in this entry, suppose it matches with entry, the second entry, then that means it will be destined for network B. So this packet will be forwarded to interface 2. It will match with which entries that this destination IP prefix will match with which of the entries in the routing table or forwarding table. The interface ID will be selected forwarded. Okay. Now what this type of addressing is actually classless addressing, where there is a notation to denote the IP prefix length, that is /16. 16 means that is the length of the IP prefix. So in classless addressing, what happens? It sometimes happens that the destination IP prefix can match with several entries in this table. Suppose it can match with 16-bit prefix, or can match for 19-bit prefix, can match for 34-bit prefix. Then if suppose it matches with these 3 entries, so then what I will do? I will send the IP packet to interface 1, 2, 3 all. No, that should not be. So in that case, which of the if there is more than one matches in this prefix matching, more than one prefix matching from the routing table, so in that case the longest prefix will be selected. Suppose this IP address matches with this 3 IP prefix. So in that case, which of the entries has highest prefix length? This is 16, this is 19, this is 24. So 24 is the highest among the 3 matching. So I will select this 24 bits. That means longest prefix match will be selected for the corresponding interface ID. So C network will be chosen. So interface IDs 3 will be chosen to forward the packet. So there can be only one entry match, then there is no problem of confusion. But if there are more than one prefixes matching, then we will select the longest prefix matching. So this can be this type of more than one prefix matching, and then to select the longest prefix one. So that example we can see it from here also. For example, what I have to do, I have already told you the destination IP address is 200.150.16.128. So what I will do, I will convert it into, I will extract the IP prefix from this destination address, and I will start from the longest prefix, because if I start from the lowest prefix, though it matches with lower prefix, but if there is any longer prefix for which that IP prefix of the destination address match, then we have to select the longest one. So that's why I will start selecting from the longest prefix. So longest prefix here is 27 bit. So what I will do, I will extract the IP prefix of 27 bit from this destination address, and I will convert this in binary, and these also 27 bit IP prefix, I will convert it into binary. If the leftmost 27 bits of this IP prefix, of 27 bits is matched with the leftmost 27 bits of this destination IP address, then obviously this packet is named for network B. So the corresponding interface ID is there, that will be chosen forward the packet. So to find out this is destination address, and we have to convert it into binary equivalent, so that the 27 it will be compared. It's like 24 bits will be compared with this 27-bit IP prefix. Okay. So if you see, the first octet is similar in both cases. So 200, 200, there is no problem. In second octet, here is destination IP address for second. Second octet is 150, here also 150. So it will match. So first octet and second octet, 16 bit is over. Then third octet means 24 bits. There is from leftmost part. It is 68 and third octet is also 68, so no problem. So now I will check only the last octet, 64 bits, and this is 118. So what is that? First I will convert this into binary equivalent. So it will be 200, which is first octet. Next second octet will be 150, and third octet is 68, and the fourth octet is 118. So I have to convert this octet into binary equivalent. 111 means maximum power of 2 can be there, will be 64, because 128 is greater than 118, so the next power of 2 will be 64. So how much remaining? 4, then 54 is remaining. So among 54, the highest power of 2 can be chosen, 32. Next remaining is 22, so 16 will be chosen. Then next remaining is 6, 4 will be chosen, then 2 is remaining, then 2 is chosen. So what will be the binary equivalent for this 112? Now 1, 2, 4, 8, 16, 32, 64, 120. So that is the binary equivalent. And among this, and this is the leftmost part, and I have to compare this with this prefix. So this prefix rate is 27 bits. So after this it is 24 bits. After this it is 24 bits. Then from this 3 more bits will be used for prefix matching. Then only it will be 27 bits. So that means 3 more bits plus this one. This 27 bits would match with this if this packet is meant for this network. Okay, because it is 27-bit prefix. Now what is I will write the binary equivalent of this IP prefix for computer network D. So it is just like 200 first octet, then second octet is 150, then third octet is same 38. Only the difference is 64. So 64 means if we convert it into binary, so it will be 200, because there is no need to convert this leftmost word, because that is already equal with the destination IP address. Only the last octet will differ in this case. And if so, I will 150, 68, and 64 means 1, 2, 4, 8, 16, 32, 64, 120. And among those, only this is the 27-bit IP prefix. Now, if we see the third octet for both destination IP prefix and network IP prefix matches, but here the next 3 bits are 010, and here the next 3 bits 011. That means this IP prefix of 27 bit does not match with the destination IP address. That means so destination IP is not meant for computer network D. So next we will come to next lower IP prefix, which is of 24 bits. So the address is differential. So what is that? I will write it into next page. So what is that? Now the destination is IP packet is like 200, then 150.68.118. So it will be 200, 150, 68, 0111, 0110. And in this case, what will be the prefix length? Because here the prefix entry will be compared with this prefix entry, prefix entry, and which is 24 bits. So I will take up to this much only. That is 24 bits. That is the destination IP address. This. And if we see that corresponding C network, what is its IP prefix? It is that 200.150, then 680. This is the IP prefix for this. Which one? For this computer network C. So I can see here that if it's only 24 bits is for IP prefix, and the remaining bits are different. So 24 bits. Okay. Now if we compare this is the destination IP address 24 bits and its value is 200, then 150, 68. Here also the computer network C, the IP prefix is 200, 150, 68. That is a 24 bit. That means IP prefix here is 24 bit and it matches with the destination IP prefix. So it is the longest matching till now, longest prefix length matching. So that's why this particular packet, which is for address 250 or 150.60.108, that will be sent to network C. So that means that repeat interface ID 3 will be chosen. Okay, that is the thing. Now you can tell me that what about the others? For experimental purpose, we can see that whether this destination IP prefix match with the lower prefix length or not. That is for 19-bit prefix, 16-bit prefix or not. That we can see experimentally whether it is matching with these entries also or not. That means if there is more than one interest or not. I told you already, if there is a match of more than one interest, IP prefix match, then obviously I will select the longest prefix match because it becomes a more specific. That's why I have started from the longest prefix. Now I will just starting purpose, I will see whether this matches with 19-bit prefix or not, destination IP prefix. So what I will do, so in that case 19-bit means 2 octet will take 16 bits, then 3 more bits will be taken. So now if I write the destination address is 200, then 150, then 68, then 118. So 16-bit and 3 more bits will be taken because it will be compared with 19-bit prefix match. So I will convert 68 into binary equivalent. So binary equivalent of 68 0 1 2 4 16 32 64 0. That is the binary equivalent binary equivalent of 68, and it will be compared with the prefix which is of this 19 bit. So it is 200, 150, and this is the prefix length which is 19 bit. Okay, this is 180 bit. And what is the IP prefix for network B, which is 200, 150, then 64 0/90. So /90 1 2 4 is 16 32 64 120. So what is the 19 bits IP prefix? It is like this. 19 bits IP prefix. It is 19 bits. So it is a destination. For this destination IP prefix 19 bits, and that for corresponding network B, the IP prefix first octet 200 is same. but second octet 150, 157. Now if we check the next 3 bits, it is 010 in the destination IP prefix and IP address, and also in corresponding IP prefix in the table for network B, that is also 010. That means this package is also matches with the prefix entry, that is for network B. So in the but I have chosen 24 bits because it has the longest prefix length. So there is, I can see here, there is multiple prefix matching for this particular destination IP prefix. And similarly, if we choose to see whether it matches this destination IP prefix matches with the IP prefix for network A or not, that we can check. So that is, here IP prefix is of 16 bits. So that means first octet and second octet, up to second octet, that will be the IP prefix length. So here first octet is 200 and then destination IP packet first octet is 200. Then in second octet 150 and 150 in a destination IP address. So first 16 bit also matches. So first 16 bit of destination IP address match with this IP prefix for network A. So that destination IP prefix match with also computer network A, but it has less length, 16 bit length. So that is that I can there can be more than one matching or entries in this. There can be more matching in this table, but if there is more than one matching, I have to select only the longest prefix match. That means I have to select this prefix which is meant for network C. So the corresponding interface ID 3 will be chosen for this particular problem. So for this particular problem, which of the interface will be chosen? The interface 3 will be chosen for forwarding the packet. Interface 3 will be chosen. And if it was the case that the destination IP prefix does not match with none of the entries in the IP prefix, then by default I have to choose interface 0 to forward the packet. That is the concept. Now, okay. Now I will what I will do. This is the problem that has been solved in this way. Now I will give an example, which is, you can take it like a homework, and I will tell you that question, which is similar way this can be solved. So that is your task to do that homework and then give me comment me the answers which for the particular problem which I'm giving as homework or task. And you have to solve it, and if you are interested to solve it, then and also to get know whether it is right or what is the right answer, then you tell me the answer, then I can tell that which is the correct answer or not. So the problem I'm giving, I will just give you the problem, similar type of problem, but which is also for, you can take it as practice party, not just now the question is that this is called classless addressing, and there is also what will be the entries in the routing table. The entries in the routing table is prefix, and here is interface ID, interface identifier. I'm just writing the problem, try to solve it, then that will be so that you can understand how this problem you have understood or not. The prefix is 131.50. 131.0.0/12, and the interface identifier is read. Next prefix is 131.28.0.0/14. Interface executed with this prefix is 5. Next prefix is 131.19.0.0, which is 16-bit prefix, and interface is 2. The next prefix is 131.24.0.0, and prefix length is 15-bit/15, which is meant for interface identifier var. Now the question is, suppose a packet has reached the incoming packet and the destination IP address in the incoming packet, destination IP address for the incoming packet in incoming packet, destination IP address in incoming packet is that was 131.23.151.76. Now the question is, this packet will be followed